All right, guys. On Friday, we did long division, which could it be a little tedious? Yeah. How easy was it to miss a sign? Very easy. Yeah, you can mess up a lot. Today, I'm going to teach you synthetic division. This is probably, I'm willing to bet none of you have seen this before, unless you're retaking Algebra 2. You've probably not seen this. Synthetic division is way faster than long division. It can't be used for everything. It can only be used for things, make sure you make a note of this, when they're in the form x minus a, meaning it's just x plus or minus, it could go either way, a number. Okay, so if I'm asking you to divide by x plus 5, you could use this. If I ask you to divide by x minus 2, you could use this. But if I ask you to divide by x squared plus 5, you can't. If I ask you to divide by 2x minus 3, you can't. It has to just be x and number. Okay? Which you're like, great, how often do I do that? You're actually going to use this a lot, especially in the next section coming up. You'll use this method quite a bit. All right, so the steps for this, and just kind of hang with me because this is very new for you guys. But once I show you a couple, you'll be like, oh my God, that is so much faster. Okay? So you're going to write the coefficients. What's a coefficient? The number in front of your variables. So you're just going to write the coefficients, including zeros, meaning the ones that kind of jump, that went x to the fourth, x cubed, x, and missed the x squared. You'll have to put a 0 in for that. If you forget your zeros, it's wrong. That's probably the only downside to this. Okay, so you have to make sure you're watching for those zeros missing. Okay, and you'll make sure it's in standard form, as we always do. You're going to omit. What's omit mean? I use that word, and people I've found don't know it. Right, skip it, don't do it. Right, leave out all the variables and all the exponents. So all you're doing is writing down numbers. Okay? For the divisor, so what you're dividing by, you will use the opposite sign of a. Or think about it as, or the, I don't want to use the word 0. Or the answer, if set equal to 0. Like if I had asked you to solve it, like we've gotten used to, you know, we can solve those in our head, right? Tell me what the answers are. It's like you're using the answer this time instead of the actual parenthesis part. So hang with me. Let me go through a couple before we start to freak out on me, okay? Because this is very different. So the first thing I look at when I'm looking at any kind of division problem is, what am I dividing by? Can I use synthetic division? Yeah, it's just x and then plus or minus a number. So I can use synthetic. Then I look at, okay, what my other part is anything missing? Do I have any zeros? No. I went x cubed, x squared, x to the first, and then my number. So I'm not missing anything. All right, so I'm going to set it up by just writing the coefficients and kind of leave a space in between. So what's the coefficient here? 1. Exponent's 3. Coefficient's 1. And then 5, -7, make sure the signs stay with it, and 2. Okay, so that's that first step, is writing all of your coefficients. And then instead of doing our normal radicand for division, it's almost like it's backwards. It's upside down. It's this kind of weird looking box we write underneath there. Notice how I left space underneath? I'm filling numbers in there, so make sure you leave space. The number I'm dividing by, normally we kind of write that over here on long division, right? Same idea, except I'm not going to write x minus 2. What would x equal? If you set this equal to 0 and solved, x equals 2. So that's what goes over here, is 2.
So x plus 2
-2. Yep. All right, that first number that you've written down, whatever it is, it always just drops straight down. I draw an arrow every time, just as almost like a placeholder, so I don't accidentally put stuff in the wrong place. Now, if you could multiply and you can add or subtract, you can do this. Okay? Either way. All right, so first thing you do, you always multiply this number out here with whatever's down here. So what's 2 times 1? Then that gets written underneath the next number. And then I'm going to add or subtract depending on what sign's there. So 5 plus 2 is 7. Then we multiply. What's 2 times 7? That goes underneath the next one. And then we add, what's negative 7 plus 14? 7. Then we multiply again. What's 2 times 7? And then you add 2 plus 14 is 16. I'm almost done. This started x to the third. If you divide it out in x, what am I down to? X squared. So this is going to be x squared. I'm going to step it down. The next one would be x to the first. Then you always have your constant, which means this must be my remainder. I'm done. So since this started x cubed, and we're always taking one of them out, I can't do it if this is an x squared, right? So this always steps down by 1. So x squared, I just filled them in. X squared, x to the first, constant. I just filled it in. Now, I want to do this problem again. You don't have to write it down if you don't want to, but I want to show you what it looks like with long division so you can see the difference. Okay? So if I had set up the same problem with long division, let's see how it looks. So you can kind of see where some of these numbers are coming from. All right, so what do you multiply x to get x cubed? We would distribute, get x cubed minus 2x squared. Change your signs. That gives me 7x squared minus 7x plus 2. We'd start again. We'd multiply x to get 7x squared. Distribute. There's 7x squared minus 14x. Do you see some of the same numbers showing up? Change your signs. That gives me 7x plus 2. Start again. We multiply x to get 7x. 7x. Negative 14. Change your signs. 16. 16 over x minus 2. Same answer? A whole lot less work? Yeah. You like long division? Yeah, your quiz on, we're shooting for Wednesday this week is your quiz. Don't make that face. Your quiz will be, half of it will be long division, and the other half you have to use synthetic division. You have to know how to do both. Yes? It depends how attendance is, whether I put it on third quarter or fourth quarter. I know some of you are like, please give me a boost at the end. All right, let's try another one. Okay, again, first make sure what I'm dividing by, can I actually use synthetic? X plus 2, yep, it's just x and a number, so I'm good there. Am I missing anything? X cubed, x squared, x to the first, number. So I got everything. So we set it up with just your coefficients. So 1, negative 14, 51, negative 54. What am I going to be dividing by? Negative 2. Right? Because if I asked you to solve this, you would tell me that x equals negative 2. The answer. All right, so we drop the first one down. Again, I put my arrow there so I don't accidentally put stuff in the wrong spot. All right, it's my little placeholder. Then we multiply negative 2 times 1. And then we add, so to speak, but it's negative 14 minus 2. Then we multiply negative 2 times negative 16 is 32. Again, if you need a calculator, you could use one. 51 plus 32, 83. Negative 2 times 83. Good. Negative 166. And then negative 54. Negative what? 220. Good. All right. So if I go to fill things in, what's this one going to start with? X squared, right? Because this one was x cubed. So this one will be x squared. It always drops down by 1. Minus 16x plus 83. So what's the negative 220? It's my remainder. Plus, that's my remainder over x plus 2. for my x's, it's always one less than where you started because I'm dividing one of them out. So if this had started x to the 5th, then I would start x to the 4th. It's always just one less than where you started. How are we feeling so far? Pretty decent? You kind of understand it, so you're ready to walk out of, so you're ready to walk out of here on a kinda? Yeah, if you gotta go, you gotta go. All right, guys, why don't you go ahead and try number 9 on your own. Give it a go. All right, so on here, I went ahead and set it up, put all my coefficients. Should there be any x's anywhere on your page when you write that down? No, don't write any x's there. All right, so then we multiply. -3 times 2 is -6. 1 minus 6 is -5. -3 times -5. -8 plus 15, 7. -3 times 7. And 5 minus 21 is -16. So this started x to the 3rd. We drop it down by 1, so this is x squared minus 5x plus 7, and then this must be my remainder. And again, the more you do these, like, you start flying through them. They get a lot better. All right, take a look at number 10. First of all, can I use synthetic with it? Yeah, I'm dividing by just x minus 7, so I'm okay. Is anything missing? The x squared's missing. Yes, you need to put in a 0. So my coefficients, I'm going to have a 1 from here, and then my x squared should be in here. I have to put in a 0 to placehold that x squared. And then I have -57 and then 56. What am I dividing by? Good, +7. All right, if you would forget to put that 0 in there, that changes your entire problem, and it's going to be wrong. All right, so we multiply. 7 times 1 is 7. 0 plus 7, 7. 7 times 7, 49. -57 plus 49 is -8. 7 times -8 is -56, and then that gives me 0. So how do I start by filling my x's in now? Good, that's x cubed, so we drop it down by 1, so we have x squared plus 7x minus 8. What's the 0 represent? Did somebody just make that noise? All right, there is no remainder. So is x minus 7 a factor of this? Yes, because there's no remainder. I love that picture. It makes me laugh. Sid. Okay, how about number 11? What? Why can't I do it? There's a lot of things wrong with it, right? It says divide, use synthetic division. Can I divide by something that looks like that with synthetic? No. So this one I cannot divide with synthetic. It's possible. Should you be able to recognize it? Yeah, you should be able to recognize that. Now, if the directions just said divide, could you use long division? Yeah, you could. All right, so I'm still going to use synthetic, but I'm going to kind of shift your directions just a little bit. And again, this is me trying to baby step you into the actual solving of these big things that I can't factor anymore. Okay, so use synthetic division and the given factor to completely factor the polynomial function. So am I solving for all the answers? No. I mean, you could, but that directions just want you to factor completely. So normally what the problem is if I look at this and I would ask you to solve this, let's say I didn't give you anything, you'd have 1, 2, 3, 4 terms. You'd be like, all right, 4 terms, I can factor with 4 terms, right? Okay, don't write this down, but let me show you. If you had tried to factor this with the 4 terms, you'd be like, all right, I'll group my first 2, group my last 2. What would be your GCF here? X squared. So you'd have x minus 3. GCF here? Negative 2, right, because that was negative. So we'd have 5x minus 12. Would I be able to factor that? No. So not everything with 4 terms factors. So this is why we're learning this new process, because we're going to be able to use some graphing calculators to help us out later on this week. But the problem is not everything factors. So if I can at least have one of the factors to get me started, I can then turn it into something I can factor. So that's what we're going to do right now. So let's use synthetic first with this. So we'll set it up. 1, negative 3, negative 10, 24. What am I going to divide by? Positive 2. So let's do our synthetic. 2, negative 1. Okay, negative 2. Good. And 0. If I'm asking you to factor it, should you always have a remainder of 0? Yeah, because can you factor with that crazy remainder on there? No. So if I'm asking you to factor and you do it and you don't get a 0 at the end, you messed up somewhere, okay, because you should. All right, so if I fill in my x's now, what do I have? X squared minus 1x minus 12, no remainder. So the directions, though, ask me to completely factor it. Can you now factor this? Yeah, it's down to an x squared. I can factor that. My 2 sets of parentheses. What are your signs? Plus and minus. X and x. Plus 3 minus 4. Yeah, I can factor that. So if I asked you to completely factor the polynomial, am I done or am I missing one of them right now? That would be if I asked you to solve it. If you circle this as your final answer, I'm taking a point off. No, I don't need, nope. He gave you one of them. Don't lose a point because you forgot the given, okay? Now, if I had asked you to solve, which again later this week we will, again this is baby stepping. If I asked you to solve, yeah, you'd have negative 3, 4, and 2. You find your answers. Right. Yep, we're bringing everything together here. Slowly yet surely we're putting it all together. Okay, let's look at another one. Again, use synthetic division in the given factor, so I'm giving you one of them, to completely factor the polynomial. Are you solving? No. I want to make sure we're clear on that. All right, so am I missing any pieces before I set this up? No, so I'm not missing any zeros. So we'll fill it in. 1, 4, negative 9, negative 36. What are you dividing by? Negative 3. Good. All right, so negative 3 times 1. 4 minus 3. Negative 3 times 1. Negative 9 minus 3. Negative 3 times negative 12. Negative 36 plus 36. Again, you should, if I'm asking you to divide, you should have a 0 there. Fill in your x's. Where do I start with? X squared plus 1x minus 12. That looks very similar to the last one, doesn't it? Set up your parentheses, signs, plus minus, options for A, x and x, 12. Good. Positive 4, negative 3. It's just the opposite as the last one. And then don't also forget x plus 3. Yes. Don't matter. Wherever you want it. So you put, yeah, since your factors are technically being multiplied, I can multiply in any order. Doesn't matter. Okay, take a look at this. Again, the wording changed just slightly. Given 1, 0, write the polynomial in factored form using synthetic division. Just notice I spelled division wrong. I forgot an I. Sorry. So what changed? How is this different? Yeah, they gave you x equals negative 4. They gave you the answer. So what am I dividing by? Negative 4. They gave you the answer that I'm dividing by. All right, so let's set it up. We have 3, 13, 2, -8. What am I dividing by again? -4. If they give you the factor, you'll have to switch the sign. If they give you the answer, then I just use what they gave me. So -4. Again, it'll be kind of a red flag because I'm asking you to divide. So if you accidentally switch it and you don't get a 0 at the end, you know you did something wrong. Okay. So -4 times 3? -12. There it is. It's Monday. It's okay. I get it. 13 minus 12. -4 times 1. 2 minus 4. -4 times -2. -8 plus 8. There's my 0 I want to find. All right, what am I starting with? My x's? X squared minus 1x, oh, sorry, plus 1x. I'm changing my own signs up here. Minus 2. All right, can we factor that further? Signs? Options for A? So 1x and 3x, is that what you're trying to tell me? Okay, I'm not there yet. Options for C. I try to go through the same process every time I factor. So I'd be 1 and 2, and I'm taking it, Ramon wants the 1 there and the 2 here. And again, if I check, that gives me 3x minus 2x, so I'm okay. I still need to bring down my given. Be x plus 4. Good. Yeah, it's that flipping in and out of that factored form to the answer. Always switches your signs. How are we feeling? You want to try the last one on your own? All right, give it a go. Yes. All right, so first thing, let's set up your synthetic. So we have 5, 19, 16, -4. What am I dividing by? -2. Right, because they gave you x equals -2, so we always use the answer up front. All right, drop the first one down. -2 times 5. 19 minus 10. -2 times 9. 16 minus 18. -2 times -2. Positive 4. -4 plus 4. 0. All right, filling in my x's. Plus 9x minus 2. Okay, factor this. Plus and minus 5x and x. Then what? 1, 2. My signs are backwards. Good. Like that? Good choice. Good, that would be x plus 2, because this was my answer, so it flips back in as an x plus 2 in factored form. Good. How we feeling? Again, we're baby stepping, guys. Later on this week, tomorrow we're going to do an activity where we work on both long division and synthetic, kind of getting practice going back and forth using which one when. Then we're going to take our quiz on Wednesday, and we're going to start moving into the full-fledged solving, like using the graphing calculator. Like if I don't give you one of the zeros to start, one of the factors, how do I go from there? Kind of thing.